Okay, let's talk about Unit 7. Unit 7 is memory. There are a lot of models of memory and different memory vocab terms that can be confusing. So let's start with the most recently accepted model or step-by-step process for storing memory, if you will. This is the model that tends to be the one that is probably the most accurate. This is the multi-store model of memory. This is Atkinson and Shriffin's three-stage model, and this is based on kind of this newer idea that memories don't just either fleet in seconds or get instantly stored as long-term memories, that there's actually rehearsal that goes on, and you have this practice of your short-term, or what's known as working memory, that gets stored into long-term memory. So the first thing that we have to look at to keep everything in perspective is the word memory is somewhat problematic if you think of it in your typical schema for memory. The word memory refers to anything that your brain has encoded. So if you look at it from that standpoint, it can be something that only stays in the brain's conscious awareness for seconds. So the sensory store is a good term for something that is automatically processed, right? So every time that your sensory input, one of the five senses, is bringing in encoded data into the brain, that's transduction. It's bottom-up processing is what it is. And so once it is encoded as a sound or a smell or a sight, then your brain has to decide what to do with that. The vast majority of everything that we encode is lost through decay. It's instantly and automatically processed. But anything that catches the attention, the conscious attention of the brain, becomes effortful. But it doesn't stay in the brain for long. It's a short-term memory. So if you walk by, you see someone and you say notice their shirt or the hat that they're wearing, and it brings very quickly into your attention, then you continue to shift your focus to something else and go about your day. It would not be very long before that was also lost through decay from your short-term memory. So things that we want to try to effortfully process, we're going to have to practice those through something called rehearsal. And those are like facts and dates and things that you learn, explicit information, and you tend to rehearse it and practice it and relearn it or reread it or rethink about it. And the longer that you rehearse, the more likely it is to create long-term potentiation and store a long-term memory. And once something is stored in long-term memory, it can be retrieved. So it's brought out of long-term memory and then brought back from a retrieval process into your working memory or your short-term memory. So let's get into the model itself. So we have sensory memories. That's from somebody, a psychologist named Sperling, came up with this idea that really the first stage of any memory is encoding. So you have fleeting sensory memories like iconic or echoic memories. And so sensory memories are really just encoded encoded bottom-up processing. So any sight, like an icon, we have it underlined there so you can see the root word of icon. It's any sight data that's encoded into the brain. Echoic memories or echoes any sound that your brain recognizes. Once it's been encoded, it is a fleeting sensory memory. It can only be there for seconds at a time. The last thing that you've heard or the last thing that you've seen, those are iconic memories and echoic memories. Now through rehearsal, they can become long-term memories. Selective attention is this idea, vocab term, that you can tune things out. You can selectively, effortfully choose what you pay attention to. Of course, there's another vocab word that's selective inattention, and that's the fact that you can just blatantly not notice things that are clearly visible or audible. Automatic processing is that term that I used before. Automatic processing is the idea that there are things that your brain just instantly does not find important. It's been encoded and then it's immediately thrown away. So think about, you have five senses constantly inundating the brain with data, and it doesn't have the time or brain processing power to give the same attention to everything. So in that regard, the brain really has this hierarchical sense of what's important and what's not. So if you couldn't make judgments, if you couldn't make prejudices If you couldn't make hierarchical decisions, then your brain would give equal attention to every single piece of data that it got from your senses, and it doesn't do that. Your brain only effortfully pays attention to things that seem either like a threat, or seem interesting, or are stimulating, or might be worth noting and paying attention to. So most of the things that we encode into our brain are kind of discriminated or shuffled out and automatically processed as unimportant, and the brain focuses its attention elsewhere. Parallel processing is kind of an explanation of this process, the fact that your brain is trying to multitask 5 different sensory inputs all the time, and that's not including even the things that you're thinking about. So cognitive processes as well. So parallel processing is where we're different than computers. Computers very quickly use rapid algorithms and coding to process things serially in a series, one at a time. Your brain does not. It is constantly being inundated with competing data, which is parallel processing. So think about if the eyes, the ears, the nose, the mouth, the skin, all of that is working at the same time to take in data. Well, your brain can only pay attention to certain things, but it is processing all of it simultaneously. Effortful processing, of course, is the opposite of automatic processing. So if automatic processing is what gets thrown away through decay, effortful processing is what catches your brain's attention, or your conscious attention, and your brain pays attention to it and deems it as more important. There was another theorist. You had a question on your study guide early in the year about this, of what the limits to short-term memory were, and of course we tested this with the serial position effect and numbers. How many digits can you remember and write down? And beyond that, you have to use memory tricks like chunking or some kind of mnemonic to try to remember them. But anything between 5 and 9 items on a list, according to George Miller, plus or minus 2. So the average person is going to be between 5 and 9, but that means some people may be as high as 11 items they can remember. Some people may be as low as 3. But the general range is going to be between 5 and 9. And beyond that, beyond 9, it gets really difficult to remember a random series of numbers. You would need semantics or some kind of memory trick like a mnemonic device. Long-term memory is an entirely different category. A lot of things that we think are long-term memories are not. We know them really well, but we don't have them permanently stored in our brain as a pathway. We do have long-term memories. Think the song lyrics that you just listened to over and over and over again when you were like in 9th grade or even after that, and those song lyrics are seared into your long-term memory forever. We have emotional experiences that are stored in long-term memory, flashbulb memories and things like that. Events in our life can be stored as long-term memories. The memory of people's faces and names and there's all kinds of things that we have. And our long-term memory is essentially unlimited, that you could store anything and everything in there. So if you look at the chart, inside of your long-term memory, and we talked about this in a lot of detail in previous tests, the difference between explicit memories and implicit memories. So implicit memories are going to be things like procedures or subconscious things. Those are cerebellum things that your brain or your body can do without any conscious effort. Your ability to walk down the street is an implicit memory. It's implicit because it doesn't require effortful processing to do. The fact that you can play the guitar while singing is implicit memory. The fact that you can chew gum and write notes in class, chewing gum is implicit. So there are things that you know so well as a muscle memory or a coordination memory, a procedural memory. Those are things that are implicit. They are involved in muscular processes, or they're involved in hand-eye coordination, and they are stored in the cerebellum. So even things like priming, which wouldn't necessarily be a process, a procedure, not like tying your shoe or walking down the street or swinging a golf club or swimming, something like that would be a procedural memory. But priming would be things that are subconscious that you don't even know that you're doing. So for instance, your brain is being primed to process information when you're watching movies or seeing things in your Instagram feed or something like that. But that's the cerebellum memories. Those are things that do not require effortful processing. They don't require consciousness. But then you have explicit memories. Explicit memories are things that are stored in the limbic system of the brain and the hippocampus. Explicit memories are divided into 2 categories. You have information that is semantic, facts and knowledge. That's like, the things that you learned in school, right? Or information that you gain from reading or listening to podcasts or whatever it is that you're interested in. That is semantic data, general knowledge, trivia. But episodic memories, the example I always give is, and think of your life as a series on Netflix, and this is season 17, episode 10. Episodic memories are specific events in the timeline of your life, episodes, if you will. So semantic memories and episodic memories are the subcategories of explicit memories. Implicit memories are either procedures or priming. And remember, explicit is the hippocampus. It is with conscious recall. Implicit is the cerebellum and is without conscious effort. So if you get an FRQ question about some type of memory process, the only thing you have to do is think, does this require any conscious effort or not? And that will tell you if it's implicit or if it is explicit. So when we get into the memories themselves, specifically explicit memories, hippocampus memories, basically your brain has a series of pathways and it files things away. So Piaget's example would be that you have a schema, and then inside of that schema you might have different assimilated details. So these are hierarchies. There's an organization. You learn something about a topic, and then you have all kinds of things inside of that. Like, for instance, this is an animal, and animals have shape, and they are alive, and they have various features, and maybe they walk on 4 paws instead of standing upright. You have various different pieces of information that kind of overlap, that categorize in your brain. So if your brain wants to retrieve something, what's going to happen is, let's say you're walking through the woods and you see an animal. Well, the reason why you know it's an animal is your brain takes sight data from your eyes. It's being processed in the feature detectors in your visual cortex, and now the brain is saying, I recognize that's some kind of animal. And then it starts running through all of the Rolodex like a computer here, the example that it's showing on the screen. Does it have fur? Is it large in size? Does it look like a predator? So what your brain is doing is it's searching through all of the pathways it can find from previous knowledge and memory about, let's recognize and identify what kind of animal this is. So without even realizing it, and at the speed of electricity, your brain is running information through pathways. It's running information through hierarchies. So hierarchies, you have concepts and you have prototypes. So again, a prototype would be something that your brain defaults to, either because of previous experience or because of one massive experience. For whatever reason, your prototype in various concepts is the most readily available image that comes to mind. And the example given is if you are told to think of a professor and you write down Einstein, that's a prototype. That might be the term that comes to mind, or that you learned a topic with, a concept with. Semantic encoding. Again, semantics are things that are general knowledge, things that are based on their meaning, and not things that are episodic, we'll say. So this is the meaning of words. So if I tell you a story, you probably wouldn't remember the exact phrasing of every single phrase or sentence that I used. You certainly couldn't give a word-for-word account, but you would remember the semantics of the story. You would remember the details, the facts, the dates. You would remember the plot line. You would remember generally the dialogue, things like that. That's semantics. Schemas, that's a Piaget word for a concept. A schema is almost a synonym for a concept, for a broad category. You have a script. There are all kinds of scripts. You have social scripts. You have, cultural scripts. You have school scripts. These are schemas for processes inside of different concepts. So, for instance, when you go to school, you already know what the script is. You know the expectation from memory. You go and sit down in class, and you get a writing utensil out, and you kind of shuffle through and get settled in. These are all scripts that you kind of adhere to. And we have gender schemas, gender scripts, social and cultural, environmental. All of those things are based on your schemas that you've learned. Connectionism theory, this is a term that you see often on previous tests. A lot of questions on retakes about this, and connectionism is a literal term. This idea, again, if you think back of the example that I gave about how your brain recognizes an animal in the woods, what it's doing is it's running all of the things that it detects and that it recognizes through pathways in the brain. So if it recognizes features like fur and relative size, it's going to run all this information through pathways to see what do we know about animals that look like this. And unless, like Piaget says, you encounter an animal that you've never seen before, meaning that when your brain searches through all of its pathways for past experience, it has no idea. It's never seen anything like that before. It doesn't have features that it's ever seen or can explain. Then you get this accommodation process of trying to create a new schema. Like, I have no idea what that is. It's an alien. It doesn't have scales. It doesn't have fur. It doesn't look like any animal I've ever seen. That would be a shocking process for us. So the connectionism theory is the idea that your brain does have connected pathways. And when it tries to recall memories, what it's doing is it's tracing back through these pathways to try to create an understanding of what it's dealing with. And the same thing happens with memories, right? So when you put together a memory, it's not recorded like it is on your phone. What a memory is this is a recreation of different data. So there's what was the weather like that day when that memory happened, and what was I wearing, and how many people were there, and what emotions was I feeling. All of those things get pieced together to create a memory, and that's connectionism, the fact that your brain relies on lots of different pathways to piece together experiences. And so what's scary about that is there's probably a lot of things that maybe aren't real. They're just a creation of a brain piecing something together. And even if it's accurate, the brain doesn't remember an event exactly as it happened. It pieces it back together based on things that it has in previous pathways. So when you look at the biology of this, shifting gears to the limbic system here, this is the biological explanation of how memories happen and why memories happen. You have the frontal lobe, right, which is where people connect experiences of problem solving, thinking, data that they've known before, semantic information, general knowledge. You have the motor cortex for movement, again, procedural memories. In order for you to store something in the cerebellum, you have to first do the physical activity, and even when you retrieve memories from the cerebellum, like, oh, I want to dribble this basketball, well, that information has to come from the cerebellum to the motor cortex so that your brain can instruct your hands and your feet what to do. Even sitting down in your car and putting on your seatbelt, that's an implicit memory. You don't think about it. It takes no conscious effort. It's a habit, but it does involve motor function. Your brain has to instruct your hands and your arms, and all of those things require motor function, which you couldn't do if you didn't have your motor cortex. The hippocampus, of course, is explicit role, semantic and episodic memories. So explicit memories are stored. And again, the hippocampus is part of the limbic system, meaning that it is emotional. Most of your explicit memories are tied to emotion. So the more emotional an experience is, or the more chemicals that are in your bloodstream when an event happens, the more likely you are to store it as a memory. The amygdala has a very specific emotional response, and that is fear and aggression. So the most intense emotions that you have, even things like sexual aggression, and I don't necessarily mean violence, I just mean actual like aggression, then that's something that's going to store more vividly in your memory. And then of course the temporal lobe, you're going to have things like sound, things like how you store information, limbic processes, the recognition of sounds and things like that in the auditory cortex. And of course the prefrontal cortex is what makes you human. Those are the things that that you can recall, impulse control, decision making, personality, and so all of that decision making is based on stored memories, past experience. And remember, there's no difference between knowledge and memories. Those things are the same thing. So if you're going to make an impulsive decision, or if you're going to decide whether or not something is a good choice, you're going to have to use cognitive processes to think, okay, well, what happened the last time I jumped off of this pier into the water? Those are prefrontal cortex processes. Now, that's getting information into storage. To retrieve it, you have various vocab words that we look at. There's two kind of R's here when we look at recognition versus recall. To recognize something means that you're picking it out of a lineup. To recall something means that you're recreating it or recalling it or pulling out of your storage, your long-term storage. The term reconstruction means that your brain is putting together based on certain features. Like I remember what the inside of the building looked like, but not the street. Or I remember who was there, but not was said. Those are things that your brain does to put together and fill in missing pieces. And it can distort memories. It can change details. And that's why things like eyewitness testimony are not very reliable, because a lot of memories that are missing key details are reconstructed by the brain, and you get what's called false memories. And that's what Elizabeth Loftus studied, was false memories, of how your brain will fill in missing details because it needs to make sense of something. You get the serial position effect. This is an important topic, or an important term, I should say. The serial position effect is back to that idea that there is a limit to your short-term memory. And so if we're inputting information for the first time, we get the primacy effect and the recency effect. And basically, this is theorized as being called the serial position effect. In other words, the position of something in a series is going to affect how well you remember it. So things at the beginning of a list that you hear and things towards the end of a list that you hear are going to be the most prominent stored memories. And the things in the middle of the list tend to be forgotten, or they decay, or the details are a little fuzzier. And the reason for that is because the items at the beginning, you've had time to process them. But while you were processing the first 6 digits, the first 3 digits of a 6-digit number, I should say, while you were processing the first few digits, you weren't effortfully paying attention to the other digits. So while you were processing the first 3 at the beginning of the list, you missed the ones in the middle. And the only reason you remember the ones at the end is because they're recent enough that they're still in your echoic memory. So you get the primacy effect and the recency effect, and you lose the ones in the middle. Retrieval cues. Retrieval cues are vital for memory recall. When you're taking a test or something like that, you can use a retrieval cue, like trying to visualize the page in the textbook and remember the picture that was on the page, or remember kind of the structure of the text and where you were on the page when you read that. And that might spark something in a pathway in your brain to go back to where to find this information. Priming, of course, is anything that stimulates a thought or a cognitive process, usually that's unconscious. So again, the idea, like if someone reads to you, it says, draw a picture for hair. Well, you might draw someone with long hair, or you might have a schema or a prototype for the word hair as being like a large rabbit, and you might draw that instead. So if you hear a story without any context, or you hear verbs and nouns without any context, you might be primed to think one thing over another. Mnemonic devices are any memory trick, any retrieval cue that's going to help recall something. So when you're trying to store a list, or you're trying to remember information, somebody's phone number, the street address, or the capital of a country, or you're trying to remember order of operations in algebra, something like that, you're going to create a memory trick that's called a mnemonic. And a mnemonic device is just going to help you encode that information in a way that you can remember it. Right? You may not remember all of the order of operations, but you'll remember the acronym for it, and then you'll think PEMDAS, and then you'll fill in the blanks in your brain from all the letters, and you'll know the order of operations based on the mnemonic. And then you have the peg word system. This one would take some learning. You would have to really work to learn all of the peg words for each of the single-digit numbers. But once you had that as a long-term memory, it would be easy for you to remember any series of numbers, and you just imagine in your mind the pictures or the images, and that's using imagery, of a bun or a shoe instead of the number 2, because that has more of a meaning, more likely recall in your brain. Thinking is a little bit different. We get into the cognitive side of things instead of the memory side of things. Thinking is a cognitive process that is basically your brain's creation of what it knows. So we have things like procedural knowledge and declarative knowledge. So humans are capable of this thing called metacognition. And metacognition is when you think about your cognitive processes. So if you were to sit down and think, oh, am I being biased here? Or am I being too emotional? Or am I reading into this too much? That's metacognition. You're actually analyzing your thought process. You're thinking about your thinking. right? So your self-knowledge, your world knowledge, strategy knowledge, those are things that are known as declarative information or declarative knowledge. And your procedural knowledge would be things like your problem solving and your evaluating skills. But to get a little bit more specific, the linguistic determinism theory, Benjamin Whorf, this idea that your concept of the world is limited to the way that you can explain it. Or put another way, you can only understand what you can explain in your language. So thinking affects our language, which in turn affects our thoughts. So again, there's certain species of animals that have variations. Well, you have different variations among people too, but it's going to be more cultural when it comes to people. So if you look at different cultures, then what you have is, say, one culture's language might be structured in a totally different way than another culture's language. If they don't have possessive nouns, or if they don't have past tenses, those are going to be things that affect the way that they view the world, because they don't have a way to explain certain things, and so they can't describe it with language. And if you think about children, it makes a lot of sense. What the frustrating thing for small children, like infants, is that they cannot express what it is that they're feeling. They don't have a concept for it, they don't understand it, and they can't communicate it. So thinking, again, is just cognition. It's a term for cognition. So when we get into problem solving, there's two ways that you can attack a problem. The first one is the algorithmic way, and that's a step-by-step process. You don't deviate, you don't take shortcuts, you don't guess, you don't use your judgment or past experience. You're just following steps. So step-by-step procedure doesn't have to be a long drawn-out process, but it is a more methodical process, right? Like a formula or a recipe. A heuristic, on the other hand, is going to be something that you use kind of some judgment on, that you're going to make more of a shortcut, if you will. So you don't have the time and energy, nor do you have a procedure for every single thing. If you're like, I don't know whether or not to turn left or to turn right here, you don't have a procedure of making the decision on which direction to turn. So what your brain is going to do is going to give you a heuristic gut intuition feeling, and you're going to think, oh, well, it feels right to turn left. In reality, there's probably some subconscious process that's taking place, like, well, I know the water is south of here, and I'm heading towards the water, so I'm going to go south. So that would be a heuristic rather than a procedure, a step-by-step methodical solution to a problem, right? I think the example that was used on a previous test was, if you have a key ring and you want to figure out which key opens the door, the algorithmic approach would be to use every key. The heuristic approach would be to limit it to the smallest keys and then just try to pick one and guess. So that would be a little bit of problem solving. And again, it's not without its issues. Heuristics are not as foolproof, and they take some trial and error, whereas algorithms do not. You get the best possible outcome with an algorithm, but the reality is that it's more procedural, and it's more time consuming, and it's more step by step. So if you're trying to decide which college to go to, there's probably an algorithm for that will give you the best possible answer. But if you're trying to decide where to eat, maybe you would use a heuristic instead. It's a shortcut. Then there's insight. Sometimes you just have this thought process, and it usually happens when you stop stressing about something and walk away from it and distract your mind, and then an original thought will come to you. So insight is a completely original thought that you weren't trying to have. It may be the solution to a problem that you've been trying to solve, and once you stop focusing on it, you have this aha moment, a light bulb moment. Trial and error, again, is a type of algorithmic approach. You try things over and over again, and then it's a little bit different than an algorithm from the standpoint that it may not be based on a procedure. It may not be based on a step-by-step process. It may just be keep doing until you find the end, but it's going to be more algorithmic than heuristic. Deductive reasoning is different than inductive reasoning. Deductive reasoning is what you can basically, it's the form of deduce. What can you deduce from the information that you have available? Inductive reasoning is you're going to make an inference ahead of time. Deductive reasoning is you're going to make a judgment based on what you have available. Obstacles in problem solving. This is where we get into the things that prevent us from solving problems. So let's say, for instance, you're working on a team and you have to, whatever it is, whether you're a lawyer and you're coming up with a criminal defense, or whether you're working on a military contract, or whether you're doing an art project for your high school art class, you can run into problems when you're working on a project. And so you get fixated. Fixated is the inability to see it from a new perspective. A mental set is an approach problem, right? So if let's say for instance you're a construction worker and you're trying to solve a certain structural problem. Well, you've got a mental set in your mind training of how you're supposed to solve that problem, and that may be something that's worked in the past, and that could be an obstacle to problem solving because you need a new fresh perspective this time. Functional fixedness is a popular FRQ term. Functional fixedness is specifically about objects. You're stuck on the uses for an object. So functional fixedness would not allow you to use something outside of its intended purpose, right? So a hammer is intended to drive nails and to connect two things together, but you could also use a hammer to break open a window, or you could use a hammer claw to prop something up. You can use it as a wedge. So functional fixedness would be your inability to see multiple uses for an object. So for instance, the famous FRQ example is if you are challenged to take a thumbtack and a box of matches and support a candle on a cork board without touching the table. A lot of people say, well, the thumbtack won't fit through the candle, we can't get it through the wick, we can't get it to stick in enough of the box of matches or enough of the matches themselves. But if you were trying to eliminate functional fixedness or avoid it, you would realize you can put the thumbtack through the box and you can put the candle in the box. And so functional fixedness is a problem. And this is a common mistake, so tune in for this. Sometimes people confuse the phrasing of an FRQ. If they're asking you about functional fixedness, they want you to point out the problem. You can't see past the use of an object. If they want you to avoid functional fixedness, that means that you are finding a non-traditional use for an object. So one year there was an FRQ that said, Tim was, I don't know what the guy's name was, but let's say his name was Tim, and he's out in the woods and he's lost and he can't make it back to his campsite in time, and so he's going to have to make camp in the woods. Well, functional fixedness would prevent Tim from realizing that he can use his jacket as a pillow as he tries to sleep on the ground, right? Or somebody could use a coin as a flathead screwdriver to remove a screw. So functional fixedness means that you cannot find non-traditional uses for an object. That's what it means. Now, in terms of heuristics, this should have been on the other slide, but in terms of heuristics, there are two types of heuristics. You have the availability heuristic and the representative heuristic. Now, these are obstacles to problem solving because they're going to be a rigidly patterned way of solving problems, and sometimes that can keep you from coming up with a solution. So the availability heuristic is the quick judgment or the decision that you make based on mentally available information, right? So that's going to be something that you saw in the news recently, right? So that's going to be that's going to be something that's recent. That's going to be something that is fresh in your mind. Right, so if somebody said, write an essay about a stressful situation, and the first thought that came to your mind was talking about pandemics because of COVID-19, well, that's going to be mentally available information. The representative heuristic, on the other hand, that's going to be based on a prototype. That's going to be based on something that you have as a bias or as a judgment, right? So if you were given the same prompt to write an essay about a stressful problem, then you might write about something that's your own unique experience, not something that's readily available in your mind that you've seen all over the news. It might be something that's prototypical specifically to you. So representative is going to represent your prototype for something. The availability heuristic is going to be information that you recently read or information that you recently saw. So for instance, if somebody said somebody is more likely to die of which of the following, and they give you options, a car accident, a heart attack, or a school shooting. Well, you might think of an example where you saw that students are being killed in a recent school shooting, and that might be an example of an availability heuristic. In reality, a high school student is much more likely to die of a car accident, but that's not a vivid example that shows up in people's mind very often. In fact, that's a good example of something that you're horrendously afraid of. It causes stress. There's been a lot of discussion about the training for active shooters and whether or not it's good for students, and it's caused stress and anxiety. In reality, it's not very likely to happen at all. It's just a vivid recent example that people have fresh in their mind. It probably would be a lot more effective to train people on how to stay out of car accidents, which you are drastically statistically more likely to die from. So availability heuristics would be the mentally available example. The representative heuristic would be the prejudice or prototype that you have in your brain. Framing is an obstacle to problem solving because the way that you frame questions or the way that you frame information, the context in which you kind of wrap it in is going to affect what causes people to think. And that's why when you look at survey questions and you look at posts that people put on social media or quotes, you have to look at how they're framed. When somebody asks you a loaded question, it's a framing problem, right? So for instance, the example of framing might be like, would you be willing to risk your life if you had a 97% chance of surviving? And you might say, yes, I would participate in this activity if I had a 97% chance of surviving. That's only a 3% chance that I die. But if you frame that a different way and you say, okay, I'm going to give you this jar of candies, but 3 of them are poison and you'll die instantly. So would you take the chance of reaching in and eating a piece of candy if 3 of those 100 candies would potentially kill you? And so it's still the same statistic. It's all in how the way that it's framed. And biases. Let's get into the various types of bias. We have confirmation bias. Confirmation bias is happening a lot these days. You see it on social media. Basically, it's rather than using science and empirical evidence and critical thinking, what people do is they look for evidence or data or information that confirms what they already believe to be true. So essentially, this is the opposite of the scientific mindset. We're seeking out information that confirms our belief, right? So we have these conspiracy theories in our mind, and so we go find the YouTube videos that back up what we believe to be true. That's a confirmation bias. Instead of trying to eliminate that bias, as the funny cartoon says, it only proved what I already knew. So confirmation bias is definitely an issue that prevents us politically and scientifically. If you think about things like global warming or climate change, there's confirmation bias that comes into that. There are people that don't believe that climate change is a human-created problem, and they look for data that backs up their point of view, and vice versa. People that believe that carbon emissions from people are causing climate change, and they look for data that backs up their point of view, and that's what it is. It's confirmation bias. Belief perseverance is another type of bias and this is more political than scientific, and you can kind of see this as you think about it in your mind. Belief perseverance is when people are just dead set on believing something in spite of contradictory evidence, right? And regardless of the information that they see from reputable sources, they will not change their mind. That's belief perseverance. Belief bias is different. Having a belief in a place biases us going into a situation that already sets us up to see things incorrectly. So for instance, it's not the same thing as belief perseverance, because belief perseverance is a refusal to change your mind. But belief bias is similar to confirmation bias, because you go into a situation already predisposed to believe something is true. So you kind of have a belief or a bias, and something's really going to have to be ground or let's say earth-shaking to change your mind. Hindsight bias, that's a common topic that you've seen several times, and that's the thing where we analyze something after it's happened and don't find it surprising. The phrase hindsight is 20/20. So that's also a popular FRQ topic. Like hindsight bias is, well, I knew that was going to happen. I could see all the signs looking back on it. Yeah, but the problem with hindsight bias is it's not very predictive. Most people don't see things coming before they happen. It's really not that shocking that we see things as unsurprising after they've already taken place, right? So I know it seems silly to even give that a term, but that's a very common human thing to do, is to look back on something that we could have never predicted would have happened and say and find it unsurprising. Like, oh well, we could have seen that was going to happen. And that happens a lot when you see tragedies. you see like, a building falls down because of structural problems, or you see school violence and you look at the perpetrator, or you see, things that happen in the news. You see, people who are in economic turmoil, and the hindsight bias says, well, if you look back at all of the signs and clues, we could have seen that coming. But the reality is that most people don't. Most people can't predict those things. They just find the evidence after the fact. Overconfidence is a type of bias where this is before something happens. This is not the same thing as hindsight bias. Hindsight bias is, I'm not surprised that happened to that guy. Overconfidence is your inability to accurately judge your own abilities, we'll say. So when somebody like a teacher would ask you, do you think that you could solve this anagram in 10 seconds or less? Well, you would unfairly and overconfidently say, yes, I could do that. So it's your lack of accuracy in predicting your ability is what overconfidence is. Like, oh yeah, I could do that easily. When you watch people do something and they make it look so easy, your overconfidence bias would say, well, I could do that just as easily, and you're just not thinking clearly on how difficult something is. So creativity, this is kind of where we'll land with creativity. You have convergent thinking versus divergent thinking. You have brainstorming. Brainstorming is used to avoid confirmation or overconfidence bias. It's a great way to eliminate some of these biases, is to sit down and brainstorm ideas and to get them out there and figure out what the best possible solution is, which of course would be algorithmic. You can generate lots of ideas without even evaluating them, and you evaluate after you collect as many as possible. So that brainstorming idea is a great idea when you're coming up with topics for projects. You sit down with people and say, okay, there's no bad ideas, let's write them all down. Or if you're trying to come up with inspiration to write a novel or something like that, let's put down all the possible plot lines, and then let's analyze which ones are the best ones. So brainstorming is a good way to avoid bias. When you look at convergent versus divergent thinking, you have analytical. Convergent thinking is all roads converge to one place, one right answer. Divergent thinking is that there's one issue, but there's lots of different ways to solve it. There's multiple solutions. So instead of all converging in one place, we're going to diverge out from one place to multiple possible solutions. Language. Language is broken down into the actual structure of the language itself, which obviously is different for all spoken languages. We have phonemes and morphemes. Think phona as sound. It's the basic sound unit. Morpheme is morphous, to build or to make. So those are all the different words that you can make with the different sounds, the different phonemes. You have grammar. Grammar is the rules, right, for combining sounds or words. Syntax is the order of the words in a sentence. So think syntax, sentence, right? So in Spanish has a different syntax than English, right? Semantics are the rules that help derive meaning. So for instance, if you add suffixes like ed at the end of English words, that means they happened in the past. That's a semantic rule change where something is past tense. Theories of language acquisition. You have the naturists, people that believe that you're born with this genetic predisposition to be able to talk. Those people like Noam Chomsky. And then you have the people that favored, probably this is not very accurate. I think Chomsky's probably more accurate than Skinner. But this is the same B.F. Skinner from chapter 6 for operant conditioning. But Skinner believed that the reason why people develop verbal language is because they were trained with reinforcement. In other words, a child learns the word cookie because when they successfully tell their parents, I want a cookie, then they're rewarded by getting the cookie. So they're motivated to learn what things are by reinforcement. But if that's not exactly the case, Chomsky is probably a little bit more accurate, because if a child did not have Broca's area of the brain, they would not be able to form words regardless of reinforcing. In other words, you can't train a dog with enough reinforcement to teach them to talk. You can maybe train them to understand some basic speech, but there's a limit to that. A dog can't understand hypotheticals and things like that. The critical period is very scientifically founded. This is the idea that there are windows of opportunity in your development, so that if you're not exposed to language before a certain period in your life, then those pathways get pruned off and you would not be able to speak. And so critical periods for reading, critical periods for math, critical period for language acquisition. There's a critical period that makes it easier to learn how to play instruments, and those are just the developmental times in your life where you're much more likely and easily to acquire those things. So here's your acquisition stages. Right, when you look at how children develop and evolve, you have month 4, the babbling stage, all the way to being a year old, where you get into the one word or the holophase, holographic speech as it's called. Then you get into the 2-word stage or telegraphic speech, and that's at about 2 years old. And then after that, you form those 2 words together to make sentences. So when you look at the stages of language acquisition, children are trying to communicate by babbling. They hear verbal communication and they try to mimic that. They try to produce basic sounds like phonemes. At 10 months, it becomes narrowed to phonemes, and then by about a year old, just a few months later, they can say single word phrases or commands, declarative things like go or no. And then as they become toddlers, early toddlers, they get into telegraphic speech like I want or my ball, right? Things like that. Eat, cookie, those things are telegraphic speech. They're 2 words. And then you get into actual sentence structure. Overgeneralization is applying grammatical rules without making exceptions, right? That's something that kids do in their acquisition of language. They don't understand the grammar. They do understand the semantics. So like, I go to the store. Well, they understand that ed means past tense, but they don't understand that you have to completely change the word to went, which is obviously a high-level skill for language acquisition. All right, so that wraps it up for Chapter 7. Stay tuned for Chapter 8, which is Motivation and Emotion, one of my favorite chapters, which is not nearly as extensive as Chapter 7, but probably a little bit more interesting.